Cool. We're here to talk today about shifting our thinking from imperative to declarative when it comes to building the UI for applications. My name's Joe, and I'm here with my friend Prateek. And yeah, we're going to take you through this talk today. If at any point you want to reach out to us on Twitter, our Twitter handles are on screen right now. So yeah, if any questions that you don't get to ask today, feel free to reach out on there. So what is this talk about? So in this talk, we're going to be taking a high-level overview of declarative UI, learning exactly what it is and the ways in which we'll need to take a slightly different approach to thinking when it comes to working with such frameworks. But before we get started, we'd love to take a look at how things currently are and put things a bit into perspective.
Cool. So let me see if my slides are working. Yeah, awesome. So in the 10 years since Android has existed, smartphones have evolved radically in terms of their capabilities. And these capabilities have unlocked a lot of advanced, sophisticated use cases that we could not have imagined just a few years ago. And with these capabilities, apps can do a lot more than ever before, and users' expectations of their apps have also increased. So if you look at the timeline of developer-centric announcements over the past decade since 1.0 was announced, we've had quite a few significant changes that have influenced the way in which we build our apps today, Kotlin being one of the major ones. But if you look closely, we've not really had major framework or tooling changes around how we build the front ends of our apps. So if recycle view, data binding, constraint layouts, the libraries that were announced recently, they have assisted in the UI development process, but they were more like improvements that tried patching the rough edges of the current UI toolkit instead of introducing any radical change. So if you quickly take a look at the conventional way in which we would build a screen, not much has really changed. We start by creating a fragment layout that houses our recycler view. Then we create separate definition for our list, and then we finally wire everything together in a fragment. So if simplified the process by just using the file names here, but if you look at the amount of code one has to write to scaffold something rather straightforward, in this case, just the fragment, it's clear that we're writing a lot of code. And turns out that this is not an Android-specific problem. Writing UI code inherently has been very explicit and ceremonial. So all I wanted to do in this case was just show a hello world text on the screen, and I needed about like 20 lines to achieve it. And even if I remove the ceremonial pieces here and look at the relevant bits, there's still a lot of explicit step-by-step drawing instruction. It gets worse on iOS. So while it's uncommon for us to work directly with the storyboard's XML file, you might come across something like this when reviewing a PR. So if you ever need to reference the backing code, you'll see how difficult it is to understand. And as your layout gets more complex, this backing file will get even larger. So in this obscure mess, we just had like 2 lines that were relevant to our intent here. Writing UI code is also vaguely opinionated. So this screen on Android can be built as a fragment with the usual view groups and widgets. But if you want to avoid the lifecycle hell, you can also build this out as a custom view entirely. So essentially, there's no clear indication around best practices. And if you want to come back and change the code implementation of the screen, it'll turn into a massive rewrite. The same goes for iOS. You can either build the screen using storyboards and interface builder or build it out programmatically. Whichever way you choose, it's difficult, if not impossible, to come back later and switch the implementation out. Writing UI is also separated by language. So on Android, you write your UI layout files in XML, and then any backend styles and themes will go into a separate styles file. This layout is then inflated by your activity or fragment, which is written in Kotlin, and then the UI is hydrated with data that comes from your view model or presentation, which is also in Kotlin. So there's a lot of context switch involved. And if you've done Android for a while, you might have been conditioned into getting used to it. But this is really confusing for people who are just starting out. On iOS, you build your layout using Interface Builder, which generates an XML representation in storyboards. The views are then referenced in your view controllers as IB outlets. And then if there's an architecture in place in your project, these views will be hydrated with data that comes from, let's say, a view model. That's also in Swift. The web is no different, and This is by far the platform that has been doing this for the longest. So you write your layouts in HTML, you style them in CSS, and then you flesh it with actual data that, and logic that comes via JavaScript files. So every modern application uses some sort of architecture to reduce coupling, to make things more testable, and to isolate related logic into its own layers. But these architectures have only helped us organize our business logic. When it comes to the presentation part, we're not really doing anything drastically different from what we used to do 5 or 6 years ago. And this is sort of where declarative UI frameworks come into picture. But before going into declarative UI frameworks, it will be beneficial to understand what declarative programming is about. So declarative programming is a programming paradigm, which is a style of building the structure and elements of a program that expresses the logic without describing the control flow. And the stress here is on building structures by describing their flow and logic and letting the compiler figure everything else on its own. So declarative UI frameworks draw on that same idea by letting you describe your UI without the precise drawing steps, and then it lets the framework figure out the exact steps to build it. 3 popular native declarative UI frameworks in use today are SwiftUI, React, and Jetpack Compose. The Jetpack Compose is in alpha right now, but it should hit stability next year. So let's take a look at what it's like to build UI using declarative UI frameworks. A core idea that these frameworks are built upon is breaking the screen down into smaller reusable components. And this concept was pioneered by React. So this screen can be considered as a composition of the email list component and the bottom tab part that also serves as a scaffold for the list. The email list UI is composed using an email card component, which in itself is built up using 3 text components and an image component. So these UI components are described as a composition of fundamental building blocks instead of explicit drawing steps. So in this case, we have a vertical list of 3 text tables and a horizontal container that houses the list and the image. A regular model is used to hydrate the component with actual data, and you can already see how easy this is on the eye. So here's what the implementation would look like in SwiftUI and Compose. In both implementations, we have a row or an H stack that lays out items horizontally. We then have a column or a V stack implementation that will lay out the 3 text items vertically. And then across both platforms, the fundamental elements are laid out in somewhat of a similar fashion. So there are a few things worth appreciating here. First, this is a lot easier to read and reason about. The second, this is a lot less code that we're working with. And that's even after I account for the code for building the actual list. This is in stark contrast from a conventional recycle view implementation on Android or a table view implementation on iOS. We're now also focused on describing the UI instead of explicit steps, which means you get to iterate faster on your thoughts without getting slowed down by the salary. The code is also now in the same language as the rest of the project. So that means there's no more context switch involved. The fundamental structure of these UI functions stays the same across different frameworks, minus some of the syntactic variation. And that means it makes it much easier to understand the code from another framework, even if you've not worked in that framework. So it also makes your skills a lot more transferable. So if you know SwiftUI, you can relatively Jetpack Compose if you want to tomorrow. But more importantly, the experience of working with these frameworks is truly game changer. It's a lot of fun to write UIs this way, and once you try it, there's no way you would go back.
Now, if we look around us in our field, we can see a clear shift towards declarative approaches. React has been in place for years. We've had a recent solution for iOS, SwiftUI, which has become much more prominent in its use. And Prateek mentioned we've also had Jetpack Compose on Android, which is now in alpha release. So with these in place, there is a clear shift and a need for something. But what is that, and why is that shift happening? So let's take a look at some of the issues that we currently experience with an imperative approach to building user interfaces. So in imperative UI, one of the concerns which can cause a lot of complexity is the coupling of our layouts and the UI logic. So in the case of Android, this is our activity or fragment along with its layout file. So if we take a kind of modern approach to Android development, we have our layout logic, the view model which controls the state of that screen, along with the layout file which depicts how that screen looks. The class which controls the logic of our screen, such as the activity, will trigger actions in the view model to control its state, and the view model will pass back its state to trigger certain aspects of that screen. So this is fine, and that separation is actually great. We have a single source of truth, and our activity is observing that. However, when this state changes, the layout will need to change based on this. The problem is that we are now coupled to a completely different concern and often a different language, which is in the case here of XML. Here, we not only need to verify that these dependencies are satisfied by the layout statically, but they will be satisfied for the whole life of the program. Here we are telling our UI what it should be doing. We are not actually defining the UI of our app, and this is where the issue is. So rather than just defining the UI at the point where the state is being observed, we take that result and then tell something else what it should be doing, thus increasing the number of concerns that are being communicated with. And this also increases the scope of change. So to add or maintain a feature and to fix a bug, we often need to touch multiple points of our application, which increases the scope. And in Android, we also don't always have a guarantee that a reference we are accessing still actually exists. So finding a view by ID could end up in a null result. And whilst we have the newer view binding library to help with view nullability, it is still the case that that reference may no longer exist, and that's just protecting us from null states. And because something can be null, it can be easy to introduce bugs in any changes that we do make. So as Prateek mentioned, some UI frameworks have also been around for years. And not that time is a problem, but when they were initially built, they were not built with today's constraints in mind. We have things such as the support libraries, and other frameworks have the same kind of issues to try and keep up with the need of developers and the kind of things that users want. Now, if we try and eliminate XML from the question, try and reduce the scope and try and reduce the complexity inside of custom views, we still have the same issue of dealing with the same kind of UI framework and the constraints that it brings. That doesn't change anything. And within imperative frameworks, we also see a greater level of complexity when it comes to the management of view state and how those views are constructed from states. So let's take a look at an example of some UI. And we have a single card here that can be represented by several different states. So for the example's sake, this is a language learning app, and each card represents a course, and the user's score for that course is represented on the card. In a normal state, the card represents the name of the course and the score. If the user's favorited the course, we show a star next to it. And if there's been some error state, maybe uploading the user's score or fetching some kind of state from an API, the card shows an error state. If we look at some possible imperative style code that could be used to control this, we could end up with something along these lines. So not only do we set the text of the title and the subtitle, we then also have to modify the visibility and the properties of each of the views that card contains based on the state of the lesson. We have to change visibility based on whether there's been an error, based on whether the card's been favorited, and also set the score, but only set the score if it has a score. So there's a lot of different things you have to think about. And because all those components exist inside that card all the time, we have to make sure that when we're adding new state or modifying state, we have to take care of that. However, when we switch this to a declarative UI, things become a lot simpler because we're actually defining what the UI is based on the state. So we don't need to worry about modifying the view. We simply add the components to the UI based on the lesson object. So if there's an error on a card, that'll be shown. And then if the user refreshes the content and the card is re-rendered, the error view, we don't have to worry about changing the visibility of that because it just won't be rendered on screen because it hasn't been added to the UI in that component. And the key here is that we are defining what our UI is rather than manipulating it. This brings in a lot more predictability when it comes to the state of our UI, reducing the chances of any kind of bugs or regressions within the UI itself. And it's not just the APIs from declarative UIs that are nicer to work with, but the practices which they bring can actually help us to write better code and build better applications. So from the example we just saw, we get a collection of improvements from declarative UI. Our apps can become more stable. With the reduced changes and the single source of truth, we can be confident that our UI represents what we intend to display. And with this, things also become more maintainable because if we're changing some part of our code, we could be more confident that we are not interfering with some other piece. And this in turn makes things more testable because our UI becomes much more predictable. Now, a big concept for declarative UIs is state and the way in which this is organized. So what is state? All applications display some form of state to users. When it comes to Android apps, this could be maybe a switch that has been toggled on. That on state is state. A snack bar that shows some form of message. Maybe there's been an error that has occurred and that message needs to be shown. Maybe an item that is shown in a list, such as a news article. All these are parts of a state that represent what that screen is currently in. And when it comes to state in declarative UI, we begin to move away from this kind of unstructured state. And this is when we use view properties, as we just saw, to manually change how a view is presented. With declarative UI, we begin to see the concept of unidirectional data flow to complement this. So this is essentially one-way data flow, which means the data has one and only one way to be transferred to parts of the application. And in this concept, we have our app state, which is passed to the UI, and then the UI is updated to reflect our state. So with the removal of that unstructured state and the need to manually assign individual view properties, we can utilize unidirectional data flow to have our UI built and then rebuilt whenever state changes. And this works perfectly, as we can ensure that all of our UI components are referencing the same piece of state at any given time. And this causes them to always be up to date. And that way, we don't need to worry about individually modifying UI components outside of that global state. Now, this is a kind of high-level view, but what does this mean for the trees of components in our app? So in declarative UI, such as React or Compose, the aim is always to pass our state from the top downwards. So our parent component will receive or hold some form of state and then pass that data down through to its children as required. If any of those children or components need to trigger events, those are passed up through the components, and that way the parent component can then handle the state and the whole cycle happens again. So the aim here is to pass the state down and flow the events up, so that state management is always happening at that same point. And with these, we can already start to see a tie-in with unidirectional data flow. But how does this actually map to the UI of our app? So in declarative UI, our UI is represented by functions, and those functions are used to render that UI. So with these functions, those functions take state as their parameter, and that state represents what the UI within that function should display. So when the state of our app changes, this is going to trigger a redraw of the user interface. And here, there is no imperative changing of the UI itself. So you change the state, and the UI will rebuild, be rebuilt from scratch using the functions of the components and the required state. So we have a function for a lesson card, and that takes a state. If the initial state is error, the user will refresh the screen, and that function will be called again, and that state would have changed to some success state, and then the UI can be rebuilt based on that. So the state essentially tells that function what the UI component inside of it should be doing. So let's take this screen as an example. We have an area of the screen which consists of a list containing articles which the user can choose to read. And when it comes to the state of the screen, we need to be thinking about the different scenarios that can occur or that we can be in. So, can there be a list of items? Is the list of items empty? Have none come back from the API? Is the screen currently loading? Or has there been an error whilst we're loading that? So here we see 4 different states that our screen could be in at any given time. And we can, with this in mind, we can construct our state based on these concepts. So our state object will consist of these items, whether or not the screen is currently loading, and whether or not there has been an error. We can then use this state to manipulate our UI and define what it should show. So maybe our screen could be loading, or we need to show a list of items on the screen, or there's been no items that have come back and we display some form of empty view, or the case that there's been an error and an error view is going to be shown on screen. But how does this work? Remember on the previous slides, we talked about how we are declaring what the UI is rather than modifying individual properties. So in this case, we are creating the UI components based on this state. We're not modifying visibility properties or changing anything else related to existing components, because those components don't exist unless they're told to be there. We literally declare what the UI is based on that state that is provided. So this, for that screen, could look something like this, which would be called every time the state changes and that function for that UI component is triggered. function retrieves a state, and then it essentially renders the component which is told to based on that state provided. So if on the first run, we're loading content, the progress will be rendered. And if successful, we want to show the list of items. In this case, the UI will be re-rendered and a list will be shown. Now, because we haven't said that a progress should be shown here, it would automatically be replaced from the previous state of the UI. You don't need to worry about modifying its properties in any way. So we covered the high level state of the screen, but what happens a bit more into the component trees? So for example, the list itself here is made up of child components. And in terms of a tree, this could look like so. We have the parent node, which is the list itself. And then each of that list's children is represented by a child node. As well as the high level component state management, we also need to be curious about what happens lower down in those chains. And Prateek will go a bit more in depth into exactly what's going on here under the hood. But the core concept here is that whenever some app components need to update the state change will only update the required components. So for example, if we refresh the list and only one item has changed, the whole list won't be re-rendered. Only that item that needs to be updated will be updated. So for example, it might be the case that one of the titles on our news items changes. In this case, we'll only want to update that first child. Otherwise, it wouldn't be very efficient to update that whole list every single time. So here, a node within that list has been changed. And in this case, the compiler will detect this, note that child with that specific ID, key, or position has changed, and it will only update that component. It could also be a case that we add another item to that list of news articles. And similar as before, here, a child node will be added to our parent node, and again, the compiler will be able to identify that a new item has been added and render the update based on that. And finally, if we decide to remove an item from the list for any reason, the compiler would know that item has been removed, re-rendering only the part of UI that has been affected by that change.
Okay, so UIs are represented conventionally as trees, with the container as the parent node and other views as child nodes of the tree. So if we take a look at how we would update a tree in declarative UI, the user input would transform and emit data that is then consumed by the UI, and then through some tree traversal magic, a specific node would be updated. But when you compare this to how we would update a UI tree in declarative UI, user input would transform the backing state of the app, and this state can be a state power in Swift, a React prop, or a composable function param. This transformation would emit a new tree entirely. So there are a couple of benefits to this approach. One, it's easier to read and debug, because now when debugging these functions, you always start fresh instead of assuming a previous state. Also, one implementation will cover all cases, which makes this concise and easy to understand. The trade-offs in this case are that it seems inefficient, and rightfully so, because you're recreating the entire UI instead of partially updating a node. And that contradicts our understanding of drawing and performance. But if you look deeper, these are misconceptions rather than trade-offs. So imagine if we lived in a world with infinite resources and no compute constraints. In such a world, recreating your UI from scratch won't be that bad an idea. In fact, 3 mutations in that case would feel like a lot of work in comparison. Our code bases will then just look like a bunch of functions that message and transform data that your UI consumes. This means that our project will shave off complexity by an order of magnitude. And the benefits in this state would be you write less complex code and everything is super easy to understand and follow. But in reality, that's not the case. And while we don't have infinite resources, we can afford some trade-offs. So declarative UI frameworks trade off on performance slightly to offer the great developer experience and other advantages that Joe mentioned earlier, like proper state management model and unidirectional data flow. And the reason why these frameworks can do so is because they are optimized at the compiler level. So on surface, it might seem like we are recreating our UI from scratch, but internally, the tree is stiff and partially updated. This was pioneered by React with its virtual DOM model, where it compares the content of the virtual DOM with the actual one and updates only the nodes that would change. So we no longer need to worry about overdraws in performance, and we have these nice abstractions to work with, while the framework does all the heavy lifting for us.
So a big question probably on a lot of people's minds is, how can we get our apps ready? Jetpack Compose is still some time away until it's production ready, but we can start thinking about some of this stuff now. And whilst we're not suddenly going to go and refactor our whole app to Jetpack Compose, as tempting as that might be, it can help to start thinking about the work we're doing now leading up to then, and how it can complement the approaches that will be used for declarative UI. And as a note, this isn't about doing things for the sake of it. These frameworks will not only bring us more stable apps, but better developer productivity, and will likely also help with other things such as hiring. If there's a company already using Jetpack Compose in the early stages when it's in production and stable, that's an exciting company to work for, and that will help with things like that. So a big thing here is having a declarative mindset. Some of the things we've talked about here and things you may read out elsewhere, and actually, to be honest, most of the things we've talked about here, a lot are not specific to declarative UI, and they're just concepts taken from around tech and are things that you can already do today. So to begin with, where does the state in your app currently live and in the features and components that you're building? Start thinking about this when you're next building things. So we mentioned briefly about passing state down and flowing events up. The more of that we can start to achieve, even bit by bit, even if it's slowly, the more we will have in place ready to support these frameworks. We won't get to wanting to use Jetpack Compose and being like, oh, we've got so much to refactor, because doing work slowly, ready in time for that will help that. And this naturally leads us back to unidirectional data flow. This is something we're already doing at Buffer in our Android app and have been for some time now. And I know a lot of other companies who are doing it and people in the community who have talked about it. So as noted in the examples in this talk, having that single source of truth that represents the state of your screen, that is perfect for declarative UI and will really help with your transition to Jetpack Compose. You have this single source of truth which represents the current UI state, regardless of whether you have declarative UI or not. It's completely usable in the way we currently build apps today, and it will be moving forward too. And on that, because the Android view model and Jetpack Compose has great support for working together, utilizing the view model can help set you up for success in the future. If you're using the view model currently or are thinking about switching, utilizing it for your single source of truth, offloading your state there and ensuring that it's being used to handle any of the logic in your screen can, again, help to set you up for that success. The more that you can do here to have this in place, the smoother your transition will be when it comes to Jetpack Compose. And with this unidirectional data flow, this also gives you the opportunity to decouple your UI from the logic of your app. If you can do the work now to ensure that your UI components are free of logic around business and any kind of state that it doesn't need, making them as lightweight as they can be, when it comes to taking on Jetpack Compose, your tasks will be much smoother, as it will pretty much become a case of just switching things out as you can and making things much smoother for you. So with that said, that's it. That's everything from our side. I hope you enjoyed the talk, and I hope there was some useful snippets there. We're both really excited to get our hands on Declarative UI for when Android is ready. But yeah, I think we've got a few minutes for questions. I think we can unmute people if you want to talk and ask questions. If you don't want to ask questions here, happy to answer anything on Twitter. But yeah, we've got a few minutes now if there's anything on your mind.
Hey, Joe.
Hey.
Thank you for your talk. I was wondering if you're going to release your part 2 of your blog on server-driven UI with Compose and GraphQL anytime soon.
Yeah, they're coming. I'm probably going to do one every several weeks because I'm still in the middle of building that stuff and building it out. So I want to make sure that it's right before I write about it. But yeah, I think the next one will be out in the next week or so, week or two maybe. But yeah, that ties in very well with Declarative UI. So I think Declarative UI is perfect for that. Makes it a lot smoother.
Hi, Joe. Can
Hey.
you hear me? Hey, yes. On our company, we are doing something, like we are doing data binding, we are doing the XML and live data stuff on the view model, because we are thinking about what you're talking, right? Like to move to this compose and, subscribe to the live data and, react to the changes based on what the view model is doing. Do you think that's a good approach, what we are doing? Because we're still not moving nothing to compose, but we are waiting to, have the final version of this in prod to start moving our stuff. But this is only an idea that we developers have and start doing to maybe make the things, move easier. What is your thought about this?
Yeah, I think what you're doing, you're saying about moving stuff to view model and having that set up. I think that's very similar to what we're doing and what we have been doing, and I think that makes sense because even if you're not gonna, even for whatever reason, you end up not moving to Jetpack Compose or it gets delayed, then that stuff is still good for your app, and it's still good to have that single source of truth and that unidirectional data flow. That's still, you're still going to benefit from that either way, and I think that's a good way of doing it because, like I said, when Compose comes and people are going to want to use it, you're going to have more to change at once and you're more likely to break stuff because you're trying to refactor state as well as refactor your UI. But if you're doing the state now and, being comfortable with that, and then the UI can come later. I'm not sure if Prateek has anything to add to that, but yeah, that's my view on it.
Oh, thank you.
We have a couple of questions that have been coming through on the chat as well. I'd be happy to read. The first one, in order for Compose to only update one child node, who handles that? Is the Compose compiler smart enough to diff our whole state, or do we need to implement something for that?
That's a good question. So this is all going to be handled internally, and that's the case so far in the development lifecycle of Compose. It's built in a way where a lot of the heavy lifting that we do right now, let's say, for example, with recycler view by implementing a diffural callback, that's just now going to be internal, right? So as long as you've done the state management correctly on your end, you don't have to worry about if your UI is being efficiently updated or not. It's going to be internal to the framework now. Joe can add anything to this.
I think that's spot on. Yeah.
One other question we have, do any of the patterns such as block from Flutter translate well to Jetpack Compose?
Well, it's still very early on in Jetpack's development, so I don't think there's any opinion as such yet. What it's playing out well with is the current MVVM or any existing architecture you have. It's pretty much about how you set up your UI to observe or consume that state. So if you're doing that right now in some form in your presentation layer by observing state from your view model or your presentation layer using an observable or live data, you pretty much just have to pass down that state to a composable function and that takes care of it, right? But no, not right now. Like there's no official guideline or community opinion as such as to how these things have to be architected. It's like very early on.
And we've got a follow-up question here. As a follow-up to diffing question, does that mean we should prefer data classes for UI state?
Okay, so I won't say that data classes are exclusive for like representing state. Any way in which you're representing your state right now, that should work pretty fine. Jetpack Compose has this idea of a separate entity for handling, values that may change over time to represent, transitions and things like that using mutable state. That's a totally different thing. But for now, like you can have it the conventional way, like a live data wrapper over a model that can be observed or consumed by your composable function, and that takes care of rendering the UI. So there's no difference as such right now there.
Okay. And got to thank you on that. Adam, thank you for those great questions. Next we got from Calvin, can Compose work well in list view? Would it make list view more efficient when displaying a list since it's focused more on state?
So we had a similar question on this last time we gave this talk. I think it was, if this is the right thing. Are you asking like if it's similar to Recycle View and how the way that handles, you can display lists of content in Compose? There is a component, a composable, I can't remember what it's called. It's lazy something, lazy for, and it's basically meant to be the
Lazy
Compose version of.
for,
Yeah, that's it. Yeah, and it's meant to be the Compose equivalent of Recycle View. I think it's still an experimental one, and they're still working on it. But the idea will be that will be the replacement for Recycle View. So that diffing and stuff will be taken care of for us.
Yeah, and if you're looking for how Recycle View like translates one-on-one on Compose, there is a separate composable for that called adapter list that basically takes a list of items that you can use to generate the Recycle View, and then it comes with all the bells and whistles of a list adapter which has the diffutal callback also implemented with it.
I think did Lazy 4 replace that? Because I remember they deprecated something.
Yeah, I'm not sure, but yeah, there is something that's going to be like a one-on-one replacement for Recycle View in Compose. Yeah, but the last I checked with the videos that they had dropped, there was an adapter list implementation that took care of it.
I'm losing track with how much is changing.
Yeah.
I had a question kind of about how to use these different pieces. So there are a few different things that manage state in Jetpack Compose. There's state, and there's remember, and there's ambient. And I was wondering how these things differ and what you should use where.
So I think state's been deprecated and remember is replacing that. I have to double check that, but I remember when I was, no pun intended, but I remember when I was checking that and when I was working something this morning, I was removing all the deprecated code and state was deprecated where I was using it. I'm not sure if it was a specific use case for that, but yeah, so I haven't really used ambience too much. I think that's something around context. I haven't really looked into it, but I know of remember, you can use that to basically, I think that's the way Google I'm recommending to handle state at the moment. You can do that. So if you want to hold some, I don't know, like a Boolean or a data class that represents your screen state, you can do that. The way that I'm doing things, and I've seen a few other people, again, Google aren't really expressing too much of opinion around this, but because I'm having my state in the view model, then I'm using the live data extensions for Compose and then just observing my view model state as a composable state. And I think under the hood, that's probably doing the same thing that remember is. I don't know for sure, but I think that's doing the same thing. So whether you use remember or the view model extensions, I don't think there's too much difference there. The only thing I would say to avoid is I think using remember all over the place, if you're learning Compose, is fine. But I think this is my take on it, I think an anti-pattern will be like using a remember all over the place, like just remember individual small pieces of state when, if you're doing that, maybe take a step back and be like, should this be part of my screen state, or is this like just a small piece of state that can be here, and kind of evaluating where things should be. That's the only thing I'd say to be aware of with remember.
Thanks.
Any other questions, or if not, it's fine. If anything comes to mind afterwards, feel free to reach out to us on Twitter. I'd be happy to try and answer stuff there as well. Cool. Cool. Okay. I think we'll leave it there then.
Cool. Yeah. Thanks for having us.
Yeah. Thanks for having us. Enjoy the rest of the day.
Thank you. Great job.
Yeah.
Cheers. Thanks, Nick.
Yeah, thanks.
Bye-bye.
Bye.